In this video, we will review some operations involving rational expressions. We will add, subtract, and simplify, and we will also solve an equation. So we can see how they're similar and different. Let's start with number one, addition. In order to add any fraction, you need like denominators. But in order to see what kind of denominators we really have, we need to factor anything that we can. In this case, that means noticing the GCF right here. Common mistake is just to treat this as a single factor instead of realizing that 9 is the GCF. And you have to factor that out to see what you really have. If you remember to factor out the GCF, then you suddenly realize that these two denominators already have 9 in common, and all you really have to do is put an m plus 2 in this denominator, and of course we'll have to balance it out by putting in the numerator as well. And that's all it takes to make the denominators the same. Now when you're adding, you don't cross out the denominators like we will when we're solving an equation. You just keep your like denominator. So I'm just going to recopy that that 9 times m plus 2. And I'm going to put the numerators together. So this is going to be 7m squared plus 14m. All right, that's from doing the distributive property. And then I'm just going to bring down the plus m minus 2 from this numerator. We do have some like terms here, 14m plus 7m, that's 15m. So that will, in the end, give us 7m squared plus 15m minus 2 over 9 times m plus 2. So this is going to be the answer. You should try to factor this just in case there's an m plus 2 up there. So let's try to factor it just in case there's an m plus 2. In fact, let's imagine that there's an m plus 2 and see what this would have to be. So of course this would have to be 7m, right? 7m times m is 7m squared. 2 would have to be 2 times 1. And if this is negative, that would only happen if this were negative, since this already would have to be positive. So this is the only way I would have an m plus 2. Now the question is, does that make 15? It's actually closer than I thought, because inner we have negative 1m, and outer we have 14m. All right, if this had been a positive 1, then that would have made 15 and it would have been factorable. But as it is, it makes 13, not 15. So it doesn't quite factor. So it was close. It almost needed to factor. If this had been a positive 2 instead of a negative 2, then it would have factored and canceled. But it didn't, so that's the answer. Don't forget to mention your excluded value, that m cannot equal negative 2 because of the m plus 2. Notice the 9 does not contribute any excluded values because it's just a constant, and a constant cannot equal 0. So that's number 1. Now number 2 is very similar, but instead of addition, it is subtraction. So we do have to take care in terms of how we handle the minus sign. So there's a couple different ways to do it. One way is to change this to a plus and distribute this minus sign right now, and then go on with the rest of the problem. Now I'm going to actually wait until the next a couple steps from now. But sooner or later you have to distribute the negative sign. So we need like denominators, just like we did when we were adding. But this time there's nothing to factor. There's no GCF or anything. So, excuse me. I have these two factors. To make the denominators the same, I'm going to have to give each side what the other one has. So I'm going to have to give this denominator an n minus 1 to match the right-hand side. And I'll have to give this denominator a factor of n minus 5 to match this. All right, and I'll have to put that in the numerator and the denominator. Now, because I have all these parentheses up here, I can't distribute the negative sign yet. So I think I will multiply all this out, and then I will distribute the negative sign. Okay, distributing here gives me 4n minus 4. Now here I need to double distribute this. So, 2n times n, that is 2n squared. 2n times negative 5 is negative 10n. 1 times n is 1n, and 1 times negative 5 is negative 5. Combining these like terms, I have 2n squared minus 9n minus 5. So now would be a good time to distribute this negative sign. So I'm going to change this to a plus and then take that negative sign and move it through the numerator. Okay, that's the part that students forget to do. You have to distribute that negative sign, change all the signs. Okay, now you can combine like terms. So you keep your common denominator, and now I'm just going to combine like terms. So I've got negative 2n squared. I've got 4n and 9n, so that's plus 13n. And I have negative 4 and 5, so that's plus 1. This is not going to be factorable, so this is the answer. N cannot equal 1. N cannot equal 5. All right, so that's number 2. So we've added and we've subtracted. In both cases, we formed like denominators, and we just had to be careful to distribute the negative sign. All right, for number 3, all we're doing is simplifying. So that just means factor and cancel. And then we'll be careful to state the excluded values. So this does look like sort of a complicated factoring problem, but good luck to my STAR method people, because y'all might have a little trouble with this. Anyways, when I look at 8x squared, I'm thinking, okay, that's either going to be 2 times 4, or it's going to be 1 times 8. I'm going to try the 2 times 4 first. So that means 2x and 4x. You know what? I can already see that that's not going to work out. And the reason why I know it's not going to work out is because next I'm supposed to look at this 8. And again, that's going to either be 2 times 4 or 1 times 8. But I also know that I can't have a GCF inside the parentheses. So, for example, if I try to do 2 times 4 here, I have GCFs everywhere. So that's no good. And it wouldn't matter if I switch it around. Or even if I try to do 1 times 8, I'd still have a GCF over here. So that means the 2 times 4 option is not working. So it must be 8x and x. All right? So now, again, when I look at this, and I'm going to split that up, Again, I know it's not going to be 2 times 4 because either way I'm going to have a GCF here. So it must be 1 times 8. Now, inner plus outer equals middle. Inner, I have 1x. Outer, I have 64x. I'm trying to get a middle of positive 63. So that means a negative 1 and a positive 64. So that's negative here and positive here. And then a negative times a positive does give me a negative for the negative 8. So this is now factored correctly. All right, similarly for the denominator, 7x squared can only be 7x times x. Now 16. 16 is either going to be 4 times 4 or 2 times 8 or 1 times 16. So I just need to play around with that. Let's try 4 times 4. Inner plus outer equals middle. Inner, I have 4x. Outer, I have 28x. I'm trying to get 58. This is not going to make 58, so 4 times 4 didn't work. All right, how about 2 times 8? Inner, I've got 2x. Outer, I have 56x. I'm trying to get 58. Okay, well there you go. If both of these are positive, that'll give me positive 58. And a positive times a positive is a positive for the positive 16. So this is now factored correctly. All right, so now would be a good time to state the excluded values. So x cannot equal, now if I take 7x plus 2 and set that equal to 0, that gives me 7x equals negative 2. If I subtract the 2, dividing by 7 gives me x equals negative 2 over 7. So x cannot equal negative 2 over 7. If I set the x plus 8 equal to 0, I get x cannot equal negative 8. So these are the excluded values. All right, so we did that aspect of it. But as far as simplifying, we need to cancel out the factors that are the same. So if we cancel out the x plus 8s, then that leaves 8x minus 1 over 7x plus 2. So this is the answer, and these are my excluded values. All right, so finally we have to solve this equation. Now, when you're solving equations, we're going to find like denominators just like we do for when we're adding and subtracting. The difference is once we get our like denominator, we're going to cancel out the like denominator. That's the difference. Okay, so let's make like denominators. I see x and I see 3 and I see a 3 and an x. So I think we can make all of these denominators into 3x. So I can just multiply this by 3 as long as I do the same thing in the numerator. This already has 3x, so I don't have to do anything there. And then this needs an x, so I'll put an x in the numerator and the denominator. Now, be careful with this negative sign, this subtraction. A common mistake is students will forget to distribute that negative. So what you want to do is make this a positive and then distribute the negative by changing all of these signs. So this will be negative x and negative 3. So now when I cancel out these denominators, which we only do when we're solving an equation, see the equal sign? All right, I'm going to distribute here, so that's 3x plus 12. And then here I have minus x minus 3, not plus 3, minus 3 is equal to 5x. If I combine these like terms, now I've got 2x plus 9 is equal to 5x. Subtracting 2x from both sides is going to give me 9 is equal to 3x. And then dividing both sides by 3, that's going to give me x is equal to 3. Now let's just check our excluded value. X cannot equal 0. So 3 is fine, so that is the final answer.